How did the urinary bladder evolve in land animals? Have you ever wondered how the urinary bladder came to be in land animals? The evolution of the urinary bladder is a fascinating journey that highlights the adaptability of life. The urinary bladder evolved primarily as a specialized storage organ for urine. This adaptation provided a significant evolutionary advantage. It allowed animals to control when and where they releases urine. This control helped reduce the risk of being detected by predators, as it minimized the scent trails that could be followed. Originally, the urinary bladder likely developed from a thin-walled structure found in aquatic ancestors. In many marine animals, this structure was used for osmoregulation, which means it helped regulate salt and water balance rather than storing urine extensively. As vertebrates transitioned from water to land, the function of this organ shifted to focus on urine storage. In terrestrial tetrapods, which are four-limbed land vertebrates, the bladder evolved into a more developed, muscular organ. This new structure could hold urine for longer periods. By storing urine, these animals reduced the frequency of urination. This decrease in urination frequency further helped in reducing the scent trails that predators could detect, making it harder for them to find their prey. Research using computational models has shown that animals with a urinary bladder capable of storing urine have reduced scent detection. This leads to increased distances between predators and prey, lowering the chances of successful captures. In amphibians, the bladder also plays a role in absorbing water from stored urine. This function is crucial for maintaining hydration in a terrestrial environment. On the other hand, mammals evolved kidneys that produce highly concentrated urine. This adaptation reduces the need for fluid reabsorption in the bladder itself, showcasing further specialization aligned with life on land and the need for water conservation. From the perspective of bladder health and bladder cancer, understanding this evolutionary background is important. The bladder serves as a storage organ that is often exposed to concentrated urine and waste products. This exposure can influence cellular health and potentially increase cancer risk. The bladder's muscular and mucosal structures evolved to manage urine storage and periodic voiding. However, these features also mean that long-term exposure to urinary toxins can impact the integrity of bladder tissue and its susceptibility to cancer. In summary, the urinary bladder in land animals evolved from an osmoregulatory sac in aquatic ancestors into a muscular storage organ. This evolution supports survival on land by enabling controlled urine releases, reducing predation risk, and aiding in water balance. Understanding this evolutionary history helps us appreciate the bladder's anatomy and function, which are relevant to bladder health and disease today.